Okay, good morning. The resultant yesterday we have seen the Fraunhofer diffraction due to the single slit. Okay, to the continuation of that class, uh, today we have to study about the intensity distribution, how the intensity will be going to be distribution as we observe the Fraunhofer diffraction by using the double slit. Okay, so the resultant intensity formed at any point, okay, the resultant intensity formed at any point on the screen will be the appearance of the product of both the cos square beta and a square sine square alpha by alpha square. So this is got from the double slit radiation intensity of the radiation. I is equal to 4 I naught cos square beta and sine square alpha by alpha square. So the diffraction term here is sine square alpha by alpha square. Okay, sine square alpha by alpha square gives the central maximum in the direction theta equal to 0. So it gives a central maxima having theta equal to 0, that is alternate maxima and secondary maxima of decreasing intensity on the either side of the as shown in the figure. We have seen yesterday the closely figure of the Fraunhofer diffraction due to the double slit. So for maximum intensity, for the maximum intensity distribution, we have sine alpha is equal to 0. If sine alpha is equal to 0 but alpha not equal to 0, so then if alpha is not equal to 0, we have to follow the plus or minus integral multiples, like alpha is equal to plus or minus m pi. Let m be the m or n, you can consider whatever you wish. So m equal to 1, 2, 3 and so on. Okay, so as alpha is equal to plus or minus pi and 2 pi and 3 pi and so on, so we know that we know that alpha is equal to pi e by lambda sin theta. Okay, alpha is equal to pi e lambda by sin theta is equal to plus or minus m pi. Next, so from that pi e by lambda into sin theta, so is equal to plus or minus m pi. So another product is also there, that is a cos square beta, that is cos square beta is equal to 1, sin square alpha is equal sin alpha or sin square alpha is equal to 0 and cos square beta is equal to 1, right? So as cos square beta is equal to 1, beta is equal to plus or minus n pi. So what is the beta value? So in the previous session we got the beta value also. Pi by lambda, just E plus D. Why E plus D? E plus D is the distance between the two slits S1 and S2. Then pi by lambda E plus D sin theta equal to plus or minus n pi. Then pi gets cancelled both the sides. Then E plus D sin theta is equal to plus or minus n lambda, right? Then this is the case of E plus D sin theta is equal to plus or minus n pi. Okay, so that is n lambda. So for the secondary maxima we will get odd multiples. Okay, odd multiples like alpha is equal to plus or minus 3 pi by 2 and pi by 2 and 7 pi by 2. So if we plot a graph for the intensity, that is for the sin alpha and the cos beta or cos square beta and sin square alpha by alpha square across the intensity, so we observe the sine graph and also we observe the cos graph. Okay, here you can see odd multiples and integral multiples, right? So final intensity is going to be formed both as we take an angle theta with the distribution of intensity distribution, we get the maximum intensity with a certain angle theta. So this is a theory about Fraunhofer diffraction due to the double slit. Okay.